Hello and welcome back. This is part 2 of the mole conversions video series. In this particular video, we are going to be looking specifically at converting from moles to particles and particles back to moles. In the first part of this video or this series, we talked about grams to moles, moles back to grams. This is the second part of the mole roadmap. To get you back into it, just a quick reminder that mole conversions is just the mathematical process of converting between grams, moles, and particles of a substance. Again, when we go grams to moles or moles back to grams, we're needing that molar mass, which again was covered in a previous video. So if you haven't watched that yet, please go back and do so and learn how to calculate the molar mass of a substance and why it's important. Additionally, when we're going between moles and particles, we're going to be using Avogadro's number. And again, there's a video on that you can go back and watch. So for this portion of the roadmap, where we're looking between moles and particles, it doesn't actually matter what the substance is, because as we've learned, when you have 1 mole of a substance, you always have 6.02 times 10 to the 23rd particles of that substance. And when we talk about particles, we can be referring to atoms, ions, formula units for compounds that are ionically bonded, or we can talk about molecules for compounds that are covalently bonded. So we use this term particles as kind of an umbrella term or catch-all term, rather than specifically having to say atoms, ions, etc. We just use particles. Beyond that, to be able to convert from moles to these particles, we're always going to use the conversion factor of Avogadro's number of particles per 1 mole. And again, the reason, just like in grams to moles and moles to grams, is because we need to cancel out units properly. So if our starting amount is in moles, we want to make sure that that unit is in our denominator of the conversion factor. That way units of moles will cancel, and we're left with the units that are in the numerator, those of particles. Likewise, when we're converting particles back to moles, we're always going to use the conversion factor of 1 mole per Avogadro's number of particles. And again, it's because of units. If my starting amount is done in terms of particles, then I want particles to be in the denominator of the conversion factor so that those units can cancel out and leave me with the units that are in the numerator, the units of moles. So let's go on and jump into this and start looking at some practice problems. So this first problem, it's asking you how many particles of NaCl are in 1.25 moles of NaCl. And just like in the previous video, we're always going to diagram that word statement or that word question. So how many is our question. It's asking about particles of NaCl, so I've got a substance, are in 1.25 moles. That is my starting amount. So if my starting amount is moles and it wants me to find particles, I'm going to be using the upper portion of this mole roadmap. So I'm going to take my starting amount, 1.25 moles of NaCl. And again, I'm starting with a compound, but I just as easily could have used just a plain element like sodium or chlorine. I'm using the compound just because. So if I'm trying to find particles according to my roadmap, I'm going to need Avogadro's number, so 6.02 times 10 to the 23rd particles of NaCl, and we typically abbreviate that as part, and then per 1 mole of our substance. Again, we'd verify our units because we'd multiply by our numerator, divide by the denominator. We'd see that moles NaCl cancel, and that's going to leave me with an answer that is done in particles of NaCl. Now again, this question could have asked me how many formula units of NaCl are in 1.25 moles of NaCl. Again, we're using the generic term particles. So don't get thrown off if a question asks you for formula units rather than particles. And now I'm going to do the math. And when I do this math, there's a couple of different ways to put it into the calculator. But I'm going to start at 1.25, and I'm going to multiply by, and the first method is to do parentheses. So you would open parentheses, 6.02 times 10 to the 23rd, close parentheses, divide by 1, and hit enter, and you would get your answer. Or you can type it into your calculator as 1.25 times 6.02, and then on your calculator, if you're using a TI calculator, right above the number 7 button, there's a button with a comma, and you'll see written above that in blue, it has EE. So on your calculator, if you hit second and then the comma button, in your calculator, it will show 6.02 and then an E, and then you can type in 23 and hit enter. Either way you do it, you will end up with an answer of 7.525, and then E23, and the E is the same thing as a times 10. So you can either record this answer as 7.52 times 10 to the 23rd, or 7.52 E23, and then particles of NaCl. Either way is acceptable. So that's our first example problem. Let's look at another one. Again, if at any time you want to pause the video and attempt this for yourself and then unpause it, please feel free to do so. And you can use my work and explanation to check your work. So in this problem, it's asking me how many, so there's my question, particles of HCl, my substance, are in 2.50 moles of HCl. So my starting amount in moles, particles is my question. Again, I'm going to use the upper portion of that roadmap. So 2.50 moles of HCl times a conversion factor. Where in that conversion factor, again, I'm going to need 6.02 times 10 to the 23rd particles of HCl. And again, we could use the term molecule or formula unit, but we're using the catch-all particles. And then I need 1 mole of HCl. Notice that we did not have to calculate a molar mass in this problem or the previous problem. The reason being, we're not dealing with grams. The only time you're ever going to need molar mass is when grams are involved. And that's the nice thing about going from moles to particles or particles back to mole. All you need is Avogadro's number. So in this particular setup now, again, I'm going to verify that the units of moles cancel, leaving me with particles of HCl. And then I'm going to do the math. Again, 2 different ways to do it in the calculator, either with the parentheses or with the exponent key, that second comma button. So I'm going to type it in 2.50 times 6.02, second comma for the E, and then 23, hit enter, and I get an answer of 1.505 or 1.51, and then E24. Again, you could just as easily write this as 1.51 times 10 to the 24th, and then particles of HCl. Either one is correct. So that is going from moles to particles. Now let's look at the reverse. How many moles of HCl, so how many is my question. It refers to moles. Of HCl, my substance, are in 2.50 times 10 to the 24th particles of HCl. So here's my starting amount. So I'm starting at particles, and I want to know moles. So as a result, I have to follow the lower arrow. But I'm still going to take my starting amount and start with it. 2.50 times 10 to the 24th. And this is particles of HCl. And then my conversion factor. And in that conversion factor, I'm going to have 1 mole of HCl in my numerator. And in my denominator, I'm going to have Avogadro's number, 6.02 times 10 to the 23rd, and that is particles HCl. And now when we work this problem, this is where using parentheses is very important, or making sure that you're using that exponent key. And in this, the two different ways to work it. The first way is to do open parentheses, 2.50 times 10 to the 24th, close parentheses, times 1, divide by open parentheses, 6.02 times 10 to the 23rd, close parentheses, and hit enter. Or 2.50 second comma to get the E button, 24, and then times 6.02 second comma to get the E button, 23, hit enter. Either way that you do this, you will get the same answer. And that answer is 4.152, or to 3 significant digits, 4.15, and then moles of HCl. So again, you either need to put both of these inside of parentheses, or type it into your calculator as 2.50 E24, then divide by 6.02 E23. And the reason being is if you simply type it into your calculator as 2.50 times 10 to the 24th divided by 6.02 times 10 to the 24th or 23rd, it's going to work this problem and then divide that only by 6.02, and then it will multiply by the 10 to the 23rd, and you'll get an incorrect answer. By putting these values inside of parentheses, you're telling the calculator that you want the entirety of that 2.50 times 10 to the 24th divided by the entirety of Avogadro's number. So that's why we use parentheses. Again, if you don't want to use parentheses, then you use the E button, and what that does is it tells your calculator that this is one complete unit divided by this complete unit, and you'll get the right answer. Okay? So let's take a look at one more example. Convert 3.50 times 10 to the 23rd particles of sodium to moles of sodium. So that is ask how many moles, so how many is my question, of sodium, my substance, are in 2.50 times 10 to the 24th particles of sodium. So this is my starting amount. So starting amount of particles, calculating moles, again going to use the lower portion of that mole roadmap. So my starting amount, 2.50 times 10. Oop, I just realized I have a typo in this. Up here it's asking one amount, and down here it's asking the amount from the previous slide. So let's change up this value. My apologies that I didn't catch that. So this should be 5.30 times 10 to the 23rd. That way we've got a different answer than our previous problem. Because hopefully you recognize that if I have 2.50 times 10 to the 24th particles of anything, because I'm always going to end up dividing that by Avogadro's number, I'll always have the same number of moles. So if I had gone on and worked this with the 2.50 times 10 to the 24th particles of sodium, I would have gotten the exact same answer as the previous problem. But I want to change it up. So 5.30 times 10 to the 23rd particles of Na, and I'm going to convert that to moles. So according to the mole roadmap, I need 1 mole of sodium per Avogadro's number. So 6.0 times 10 to the 23rd particles of sodium. Which again, that particles is catch-all. Because it is just an element, the question just as easily could have asked how many moles are in so many atoms of sodium. But again, we're just using the catch-all term of particles. So mathematically, as always, you're going to multiply by the numerator, divide by the denominator, verify that particles of sodium cancel to leave us with moles of sodium, and then I do the math. Again, I'm either going to put both of these values inside of parentheses, or I'm going to type it in as 5.30 E23 divided by 6.02 E23, and then hit enter. I find it's easier to do the E. So 5.30 second comma to get the E to the 23rd divided by 6.02 second comma for the E 23, hit enter, and I get an answer of 0.880 moles of sodium as my final answer, which again should make sense, because if I need 6.02 times 10 to the 23rd to get 1 mole, and I only have 5.30 times 10 to the 23rd, I don't have 1 mole. So it makes sense that my answer comes out as less than 1. So hopefully all of this has made sense to you. If not, as always, please feel free to leave a question in the comments and I'll get back to you as soon as possible. Additionally, if you have not seen my other videos or want to see videos that I'm soon to be uploading, please remember to subscribe. And as always, if you have any ideas for a future video, please leave that in the comments as well. I hope this has been helpful to you. As always, thank you and take care.